Hi guys, welcome to Learning Electronics Repair. I have another review today. So this is from Zotek. They own the brand you have heard of, no doubt, of Zoyi. So this is one of their oscilloscope meters. They asked me to review this, and it's a while since I've done anything quite like this. So hopefully you're interested in this one. Let's take a look at it. So we have a nice little holder, instruction manual, USB leads, some meter leads, and a little one of these things. Okay, interesting. You'll notice we don't have any oscilloscope leads, and the reason for that is that this is a scope meter in its truest sense. So we have multimeter leads, no scope leads. Okay, this little switch here, by the way, moves over, and you can see it either blocks off the charging port or one of the meter ports. The reason for this, by the way, it mentioned in the user manual, is related to the floating ground that this uses. So this can be connected to high voltages, just like a regular multimeter or oscilloscope, but it's also isolated from the ground, so you can connect this to live circuitry, but that is not safe to do if you have a USB lead attached. So they've actually arranged this way so you cannot connect the multimeter and the USB at the same time. Yeah, that's a safety device. So let's have a look to see what we have here. And we are in multimeter mode at the moment. Okay. The user manual is English. Okay, it mentions here, as I just explained, about the charging port, the fact that you can't use the charging port and take measurements simultaneously. Yeah, charging port uses the same ground potential. Okay, so that's what I just mentioned about that. A quick description of the various buttons and connections, and some specifications, and importantly, how to use this. There are a couple of things we should mention straight away. So specifications for the multimeter, you can see here. Okay, resolution of down to 1 millivolt, DC voltage, okay, and a millivolts range down to 0.001 millivolts. Okay, so that effectively is a microvolt. AC voltage, so maximum voltage 600 volts on both DC and AC. Again, AC voltage down to a microvolt resolution. Resistance, resolution down to 0.01. I'll be interested to see how well this actually reads low value resistors. Okay, same with capacitors, says down to 1 picofarad. Frequency up to 1 megahertz. Okay, diode test, continuity test. Now the oscilloscope has a bandwidth of 5 megahertz. This is in a large part related to the fact that we're actually using meter probes. So this will not behave in the same way exactly as a normal regular oscilloscope. You don't have times 10 probes, for example. So because you're using meter leads, that gives you a limitation of the bandwidth. But what it does mean on the other side of the coin is you can just use the multimeter without using another probe or anything else. When you're fault finding, for example, to see if a VRM is running or something similar. So we'll test it in that way and see how well it actually works. This little item, well, I think this is actually a yeah, it's a stand to put onto the back of your multimeter, so literally like a little support. Okay, that's what it appears to be to me. This feels like it should be handheld. It just has that nice feeling in the hand. It's also all plastic, so it should be safe when used on high voltages. And of course, the other point is this has no current range on it, okay? It wasn't in the specifications. There's only 2 connections. So this will do volts and the various things, continuity, resistor, diode, capacitor, but it will not measure current, okay? So this is not exactly an everything in one multimeter. But let's see how it works as a device. Let's see if the addition of the oscilloscope function offsets the loss of the current function, okay? But just before we do that, let's see how much this thing costs. And I see a number of sellers, of course, on AliExpress. And the price is in this sort of range. So 45 euros, 48 euros, that sort of thing. Okay, with free shipping. So this is not an expensive piece of equipment. The multimeter leads are a little bit on the short side. I would say 80 centimeters, maybe something like that. You can take the little covers off. These are not the needle point ones, which I prefer, but I'll use these for the review and let's see how well they work. And let's start with the resistance test. So I'm going to do, as I always do, testing low value resistor, 0.22 ohms, 100k, 10 mega, very high value, a 1M4007 and a Schottky diode. I will just mention, by the way, I have boxes full of these components, so it's not necessarily the same physical resistor I used in the previous review, so you can't probably compare results exactly. That's something I need to take care of, but for now let's do this. So ohms range. So I currently have the multimeter on auto ranging. You can actually set to manual range, the button on the side here, so you'll see we also have manual. Yeah, it's stepping through the various options, like mega ohms. Keep pressing the button and we get back to auto. So we'll try it on auto first and then let's see if the manual makes a difference. So this is my low value resistor. It's a dual 0.22 ohms. So from either end to the middle is 0.22 and between the two ends is 0.44 ohms. What do we get? So it's saying 0.8 and 0.6, so it sees the difference between the two, and it zeros at about 0.4, so that's actually very close if we take account the zero. I don't see a zero option on this, but it does have a rel option. So if we short the leads together, okay, so reading 0.16, and we touch the power button, that will zero it, and we should get the readings relative to that. So just let it settle down, 0.6, okay. 0.5 something. That's doing better than most multimeters I will add. Let's just try the manual range. So manual ohms. Okay, again we'll just short the leads together. Hit the rel button. What do we get? It's now reading about 1.9. 1.6. So okay, I can't get an accurate reading on it, but it does read it, which is more than a lot of multimeters would do. Let's just now go to a higher value resistor. So I'm going to put it back into auto mode. Okay, 100 kilo ohms. Damn close. And a 10 meg. Which reads about 11. Now my fluke meter reads similar to that, but this one is reading about 11. Okay, How about diode mode? So I quite like this. You can go backwards and forwards between the options. You don't have to keep pressing a button. Okay, so this says diode and continuity. This is saying volt, so we are in diode mode. Interesting, the thing is right over here at 100 at the moment. Okay. 0.593. So this is a silicon rectifier diode. No bleep, just reads it. Schottky diode. This is quite fast. If you saw the review I made of the meter a couple of days ago, this is much faster. Okay, but it doesn't bleep. Short, just reads short. Okay. How about resistance continuity? Do we have that? Yes, we press the menu button and we now in ohms. Bleep. Will it blip on the diode in the continuity mode? No, it doesn't read this at all. Okay, so failed the Mr. Bleep test. Most multimeters do. Would have been really nice to see it do that, but that's what we have. Continuity is pretty fast. Okay, capacitors. So go to the resistance range, press menu. Yep, same thing works, capacitance. Again, we should have an auto and manual range. We're on auto at the moment. No, it looks like the capacitance is only auto. Let's try this on a low value capacitor. These are the lowest I have, which are 1 picofarad. What does it read? Well, it's kind of reading it some anyway. I'll hit the rel buttons if we can just get it to actually 0. Yeah, okay, now what does it read? Oh, look at that. 0. This thing reads 1 picofarad capacitors. Yeah. Not that many will do that. A lot of multimeters struggle with that. You've seen, I'm sure if you've seen my other review. So, bonus for that one. 100 nanofarads might read about 55. 61, yeah, 62. These are not very close tolerance at all, those capacitors. Try this one. Yeah, 100.4. Okay, so fine. And the 3300. The question with this is how long is it going to take? Millifarads. Oh, okay, 355. It reads it. Again, it takes some time, and this is quite common with capacitors, okay? The larger the capacitor, the longer the multimeter takes. If you want fast reading of large capacitors, get a dedicated capacitance meter. It's instant, basically. It does mention here, by the way, before testing, to discharge all high voltage capacitors. So that's checked out the multimeter functions. If there's anything else you'd like to see, well, we have the live stream coming up on Sunday. We can try it. But let's try the oscilloscope and see how well that works. Okay, so to test the scope, I've connected it to my signal generator. I've set it to 10 kilohertz. Hope you can see that. It's a bit difficult to get a camera on this for you. Let's see. So we just press the auto button. What does it do? It has it. So we have a nice 10 kilohertz sine wave there. Okay, let's go up some. $100 kilohertz. Yeah, fine. 100 kilohertz. Okay. 200k. Yes. 300k. No. Okay. Gives a strange looking waveform. It just doesn't seem to like that, does it? Yeah. Well, I've manually adjusted it and I now have it okay. Yeah, so 300k. Yeah, manually adjusted it. Let's go some more. $500. And it's saying 500. Yeah, I didn't have to adjust it again. 500k. Okay. Let's up to 1 meg. Yeah, 1 meg. The maximum it rates is 5 meg. Well, that's 2.5. Okay, yeah. Use it more. That's 5 meg. That is its specified limit. And it's doing that pretty well, to be honest. Sorry, you guys probably struggling to see this. There you go. I've got the reflection off a little bit. So 5 meg. Okay. Wonder how much more I can go. Well, that's 6 meg. 7, and it's got it. Yeah, 8, and that's where it kind of loses it. But you know what? For its specification, that's working pretty well. Given that this is a proper scope meter, so it is a multimeter with a scope display and normal multimeter leads, I have to say I'm pretty impressed with that, guys. And especially considering the price. I've also accidentally discovered you can actually change the orientation of the screen by using the power button. Yeah, like vertical, horizontal. Okay. Yeah, I like that actually. Also, let's try a few real life scenarios. So I have a motherboard here. Real-time clock on the motherboard. Let's try. Yeah, we have something there. Just go again. Well, it tells me it's running at 3.29 kilohertz. I'm on DC. There would be a DC offset anyway at 100 millivolts. So, yeah, that's pretty good. Other end. Yeah, I'm happy enough with that. I'm sure I can move the picture down. Yeah, so it's not clipping off the edge of the screen. Okay, can we trigger that? Let's have a look. We can. Oh, I'm liking this, guys. Okay, real-time clock. I won't go for the system clock because it's way out of its spec, 25 megahertz. But let's see if we can detect whether the processor reads the BIOS. So the BIOS chips are here, main BIOS, pin 1. Okay, let's switch the motherboard on and let's see if we see something. So I'm expecting a series of negative going pulses. Okay. It's there. Switched off again. I'm just going to change the settings manually a little bit on this. Okay, so we're going to go, hit menu to get to volts. Okay, and now I think it's up and down. So let's have a look. Yeah. So we go to 1 volt per division. I'm expecting this up to about 3 divisions, and then we might see pulses. So again, let's just try it. Oh yes, do you see it? That's BIOS read activity. I like this. I like the way you can easily set it manually, although it's just using a few buttons. It's not like you know, a kind of like weird sequence of pulses and presses, yeah, and long and short. Okay, so VRM. Let's try this. That might be the ground end. I might be on the wrong end now. Let's get on the other end. Yeah, let's just hit auto on this, which is a continuous waveform there. VRM running at 880 kilohertz, 20 volts peak to peak. Okay, you can see that. Nice. So that I like. Let's try a switch mode power supply. Okay, so this is the switch mode power supply I pretty much always use when I'm trying to test these sort of scopes, the ones that you can actually connect directly to live equipment safely. Okay, especially safely because you can't connect the USB. I really like that. Okay. Because, let's face it, if it can happen, it will. I've just attached a couple of crocodile clips just to keep my hands free during this demonstration. So, one is on hot ground, one is on the output of the switching IC. This power supply, 12 volts, about 2 amps, with no load attached at the moment, goes into a kind of weird burst mode. Okay, so it's not running continuously, and some oscilloscopes really struggle with this. This doesn't have any times 10 option or anything. And I was just going to test this power supply when I noticed that the maximum input voltage for the scope feature is less than 300 volts, although the multimeter is rated at 600 volts. Yeah, that's strange, but that's what it says, and I have a suspicion that this switch mode power supply is going to give me more than 300 volts, and I'm going to test that. So I have my Furnace scope attached, okay. I have the probe set to times 10, okay. DC coupling, so that's on 50 volts per division. What do I see on here? Well, it's in this burst mode I mentioned, which is like not running continuously, okay? You can see it every now and then. It fires, yeah? Well, the scope's telling me that the waveform is about 235 volts, okay? No, it's near. It's over 300. That's what I would have expected, to be quite honest. Okay, you can see it there. The power supply is running over 300 volts. So that's actually above the spec of the multimeter, and that to me is kind of a killer, because if I'm going to use this, I want to use this when repairing things like switch mode power supplies. I'm going to check with Zotek to see if that actually is a limit, because I would have thought this would take 600 volts. Okay guys, so we have to sum this one up. It was a couple of days ago when I made that video, in fact a little bit more. I contacted Zotek and I have a reply which I'm just going to show to you now. It is imperative to adhere to the specified voltage limits, as exceeding these parameters may result in the failure of the internal overvoltage protection components, okay? So I can't use this scope meter, in scope mode at least, on mains powered equipment like switch mode power supplies, no doubt inverters, HVAC controllables, all those sort of things which are mains powered, which is probably where you actually want to use this. So let me sum this one up, because this sort of affects some people and not others. What do I think? Well, there are things I like about this multimeter. First of all, I like the form factor. This is comfortable and easy to hold in the hand. The display is also bright and clear, and the menus are quite easy to use, especially as in the scope menu, and I found it easy to get into the manual settings rather than auto, alter the time base and such, the voltage range, the triggering. So I found that easy to use. I like those things. I also liked the way the display rotated in scope mode as well. Also on the plus side, it was very good at measuring low value resistors, low value capacitors, and it doesn't exactly have a zero, but it has almost as much, so you can very easily take a relative reading. So you can short together the leads, hit the rel button, and then go and measure something, and it will measure it relative to that. So rel effectively zeros the meter. And although it wasn't exactly accurate, I could read low value resistors, which most multimeters just won't do, okay? Also, it is a scope meter. Yeah, it's a scope meter. So this is a multimeter with a scope function. And although you're limited by using these sort of probes, you worked really well in that situation. I also like the fact that this has this protective thing on here, so you can't probe some high voltages while you have this thing connected to something like your PC, which is grounded, because if you did that with a grounded PC, you're not going to like the results, okay? So there are things I like about it, and the scope, as you saw during that video, that's probing around that motherboard, I loved it. Hey, this is great. And then came the problem, the big one. So it doesn't pass the Mr. Bleep test, but most multimeters don't do this. This is where you get a continuous beep on a short and a short blip on a semiconductor junction. I go on and on about this, but I know a lot of you guys also agree with me that when you're probing around on a board, you're trying to repair something, you just want to listen to the sound. You say, oh, I've got a short between the two probes, I've got a diode, or I've got some other sort of semiconductor junction between the two probes. It just means you don't have to look at the meter when you're probing. And that's something, please, multimeter manufacturers, include that feature, okay? Only a very few multimeters do it, and if you include it, it moves yours towards the top of the pile, okay? Another thing, limitation, no current range. Now, that doesn't particularly affect me, I will say this. I rarely use a multimeter to measure current. These days I have a clamp meter which will read down to 0.1 of a milliamp. I use that. Or I'm powering something from my bench power supply and I can just read the current on that. You've seen my videos, hopefully, guys, and you know I very rarely, occasionally but rarely, use a multimeter to measure current. And if I do want to do, I have plenty of multimeters, and I know a lot of you guys will have multiple multimeters. So the lack of the current range, yes, it would be a great thing to have it, but I don't see, personally for me, that as a big issue. My problem is this 300 volt limit on the scope. This thing should be designed and intended to work on non-isolated mains equipment. And at least in the UK and in the EU, and I think actually probably in most places in the world apart from the USA, we have 220 or 240 volt mains. That means once that is rectified, the peak voltage is about 320. Okay, and it also means switch mode power supplies and the sort of thing you'd want to use this on. You can't because of the high voltage on the switching MOSFET, maybe 500 volts. Anything with PFC, you can't because 380 volts or so you can't probe the PFC. And to me, and this to Zotek as well, that defeats the object of this piece of kit for me. If you are somebody out there listening to this and you're repairing motherboards and audio equipment and you're just not working on non-mains isolated equipment or high voltage equipment, that is not a problem. And I'll tell you now, that is a joy to use in those situations. Okay, but I know a lot of you will be using this for the purpose that I say, or you want to. Okay, so that's my sum up. If this thing had 400 volts plus, or even 600, which is the rating of the meter on the scope, I'd be shouting its names to the high heavens. This thing is like 40 euros odd, yeah? And even without the Mr. Bleep function and without the current, I would have been saying, guys, this is amazing. Unfortunately, I'm saying, meh. Yeah, and for me, no, that's killed it. Okay, so that is a very, very honest review. Take that as I've said it, guys. Think about what you are doing. If that limitation is not a problem for you in the work you're undertaking, maybe repairing audio amplifiers or car amplifiers or other stuff that is just not on very high voltage, have a good look at it. Have a good think. So I hope you enjoyed that review. I think that was as honest as I can be about it, get into comments down there and let me and everybody else know, let Zotek know what you think of this product, because you know, just one missed opportunity. A little bit of tweaking on that one, and I think they've got something amazing. Let me know what you think. Okay guys, thanks for watching, and I look forward to seeing you all soon on Learning Electronics Repair. Ciao for now.